Greetings, this is Artie from Artifact Electronics. This is part 2 of our Osborne restoration, and before we go ahead and test the disk drives, I thought we'd give them a little service first. Remember last time we got the machine up and running and we were able to create some disks. But before going on and testing, it's probably not a bad idea to clean these out a little bit because they've been sitting for a long time and things get pretty dirty. So this is drive number 2. It's just the one that came out first. Easy to identify because the terminating resistor socket over here is empty. I've already removed the screws, and here we are. So the first thing we're going to do is gently clean the drive head. And it's interesting because the service manual says you should definitely clean it with isopropyl. And if you absolutely have to use a cleaning disc, use it for no longer than 3 seconds. So these people are obviously, this is a Siemens drive. And obviously these people aren't too fond, or the Siemens people aren't too fond of the abrasive qualities of a cleaning disc yet. So they're telling you, don't use it. So let's put a little bit of IPA on here and see if anything comes off the head. And no, the head seems to have been clean. There's nothing coming off here. We also have the stepper motor over here, which is a little bit dry. The screw is a bit dry and the rail over here. Yeah, it doesn't exactly move very smoothly. So let's give it a little bit of lubrication. We'll use a little bit of lithium grease on both the screw. So let's and the other end. And exercise it a little bit. Take the Q-tip and get rid of any excess. You know what? This is really dry, so I'm going to use a little bit more also on the rail, of course, and a little more on the screw. And that's about all she's going to get. Exercise it a little bit. And get rid of the excess. can hear the track 0 switch happily clicking, so that's good. And that's about all we're going to do in here. Nothing was bound or nothing was seized, but it'll probably work better now. So one other thing is the door is a little squeaky, so we're going to give it some lubrication in the slot where the door slides in and out. And again, get rid of any excess. And that is pretty much the service we're going to give it. Quick visual check out, see if there's anything weird looking in here, but no, it's a pretty solid looking drive. Got a real solid stepper motor here for head movement. Not the flimsy stuff I saw on the Radio Shack drives. And things look good. So what we're going to do is put the board back in its place. But what we're also going to do is clean the edge connector. Because that tends to get dirty after a while. I'm only cleaning the top. I mean, I could clean the bottom too, yeah. Q-tip's coming back discolored. The bottom's all... Well, actually, I don't know if that's true. If this one, unlike the Shugart interface, this has a different interface because power comes in on this too, so the pinout is a bit different. But yeah, there is dirt coming off of this thing. So let's give it another pass. And it's still, I mean, the Q-tip's a lot cleaner now, but we're still getting stuff coming off it. So let me rinse and repeat this procedure till I get back a clean Q-tip, and then we'll reassemble this. While reassembling this, you have to be very careful. I mean, pay attention when you're disassembling this. What I found was there were two loose nylon washers underneath, between the board and the drive, only on the top side, the side closer to the connectors. You have to pay attention to that. Don't try to make sense out of why they're there or why not, because here it doesn't really make sense. If I put it in like this, the the PCB sits perfectly straight. With the washers, it kind of offsets the back side of it. There really is no danger of shorts here, at least not one I see, but if it was in there originally, we better make sure to put it back. While we're at it, I might as well start replacing caps, bad caps and suspected bad caps. This is the one we found that showed up as shorted on the motherboard, which seemed to be our main problem. So let's see what the tester thinks it is. Thinks it's a 0.02 ohm resistor. So yeah, I think this thing's shorted. Now for grins, here are the ones off the power supply. that generally have a high failure rate. None of them look bad or shorted, but let's see what they return. This one's supposed to be 0.1. It's an X-type capacitor. Of course, I don't have an X-type replacement, but let's see what this says first. Point 1, this one's still good. But I'm not going to put it back. I'm going to put this one back in. It's not an X-rated cap, but it'll do the job. Wow, this one's pretty accurate. And for completeness, let's have a look at the other two I pulled. These ones are supposed to be 0.01. This one's still good. Come on. And so is this one. But those need to be replaced. So let's go ahead and do that. Here's a switching power supply. We took out the time bombs, one here, and one over here. And this should work pretty good for now. It's a standard supply. The only thing that really gives away its age is probably the size of the capacitors. And the big ass transistor over here, which you don't really see on newer switchers anymore. But that should be good for another, what, 30 years? No, 40 years. Let's see. Obviously it's not going to get very heavy use, so I think this shouldn't give us any problems. Not that it gave us problems now, it was still good, but time bombs are gone. I also replaced the incoming filter caps on the power lines, the tantalums, with just regular disc caps. They were all good. I measured them out of circuit, but this is probably worth it. I wanted to originally do all of the tantalums, but I don't have, they're using 1.5 microfarads over here. I want to see if I can find 1.5 electrolytics. If not, I'll probably just put 1.0 electrolytics in here. And the only other place is here. I replaced the culprit over here, and these are still left. Same thing, these are also these are actually 15 microfarads and 1.5. They really like the 0.5s, and depending on what I can find, once I'll order the parts, and I'll also do those. Other than that, we're good. There's no battery on this board. Everything in CPM was pretty much stored on each diskette that we were using. And so everything else looks good. Let's put it back together and start running some tests. I don't know if any of you had noticed, but when I put the bypass caps in, I messed up. These are fine, but these two were basically shifted over by one pin over here. I don't know how that happened. Fortunately, I caught it before I put it back in the machine, but I mean, this pin isn't connected to anything. So I just took everything and moved it over from here to here, one to the right, and now everything looks fine. So let's continue putting it back into the machine. So I plugged everything back in. just to test before reassembling the case, and unfortunately there's still a problem. So here's drive A. It works perfectly. Formats, reads, writes, boots, everything is just great. Drive 2 reads but cannot write. I've tried formatting, I tried writing to it, formatted a disk here and then put it in here and tried to copy something to it. Wouldn't work. So I thought to do some fault isolation. I mean, at this point it can be almost anything you're looking at. So the first thing I did was I swapped drives A and B. So A became B, B became A, and the problem moved with the drive. B, I could boot the machine off of drive B, but I couldn't format, I couldn't write to it, I couldn't format it, I couldn't really do anything with it. So that kind of ruled out the cable, I think, as well as the main, as well as the motherboard, because the problem obviously moved with the drive, and all I had to do to swap them was physically plug them into each other's connectors and move the terminating resistor over to what the machine sees as drive A. Okay, so we've ruled out this, we've ruled out the cable, we've ruled out the power supply. So the next thing I did, since the drives are identical, I swapped the drive controller boards. And the problem stayed with the drive. So putting this controller board in here, it still could not write. And so that kind of rules out the controller boards. They both seem to work just fine. Now what that leaves us with is that this drive, this is the original B drive that cannot write. There's something wrong with this drive, obviously, and it should, we can find it, it can be anywhere except in the controller board, because the controller board worked fine over here. So let's see what is left here that can misbehave. First of all, it's the spindle motor, and I checked drive speeds on both of the drives, and they're supposed to be 300 RPM plus minus 5%, and they were both off less than 1% from 300 RPM. So the disc is spinning correctly. Next comes the head alignment and the stepper motor, but I ruled that out too, because the drive reads just fine, and if there's anything wrong with the stepper motor or the head alignment, it wouldn't be able to read. So what does that leave us with? Let's have a quick look at what the drive head looks like electronically. So we got it boiled down to the drive head, which we can see over here. This is the 5-pin, 6-pin connector that runs from the front of the PCB underneath the PCB and to the heads. So really all that is in the drive head assembly is a center tap coil here and a regular coil. The center tap coil is the read-write head, and this is the erase head. Shares a center tap and is driven separately. And obviously when you want to write something to the disk, you have to erase what is currently stored on it before writing a new value to it. Very much like flash memory. And the way it works is when you want to write during a format, during any kind of write operation, it goes ahead and erases a sector, a byte, a sector, I don't know exactly. It can't do it on a byte per byte basis, but it can do it on a per sector basis. Erases it, and then on the next rotation uses this head to generate the field that writes the new value to it. So my suspicion, of course, is if the erase head doesn't work, then it can't write, because essentially on every byte 255 times out of 256 it'll fail to write. That is, when the byte that's on there is different than what you're writing to it, the write will fail, checksums will be off, and the whole thing will fail. So what I did was since this is disconnected, there really isn't, when I pull the connector out, there isn't anything connected to these coils, and I just measured resistance. And it turns out that I looked in a few references, mostly were in the neighborhood of a few tens of ohms. It differs from drive to drive, but it's not that big of a difference. But what I found in the drive that can't write is when I measured this coil, it showed a really high resistance in the mega ohms. It should be like 30. So there's something wrong there. Of course, first I checked the wiring itself. I did a continuity test between the head, where you can see the wire being connected to the copper sticking out from the back of the head to the connector. And so continuity came out good. The wires are connected, they're not shorted to anything. So that only leaves the actual erase coil. So this thing is toast. It fell apart, it got too much current, I don't know, but it's not open, but it's really close to being open, because several mega ohms for a coil, that's not good. So where does that leave us? So this drive has a bad head, and yeah, I guess I could try to look for a head, but you know, they're not interchangeable with other drives, even though the resistance or the whatever henries the coils in the head measure are close. They're not the same as other drives. So I would have to find an identical drive to swap out the head assembly. And by the way, this is the connector that connects to the heads. This is what you saw in the schematics before. So when you pull this out, the coils in the head really have nothing else across them. So to me that means that's it. This drive has a bad head, and I need to find a replacement, well, replacement head, but in more practical terms, I have to find a replacement drive, and to make the machine whole again. And some of you may be saying, hey, you didn't do the most obvious test. And that is, well, the most obvious test is did the disc have a write protect tab on it? No, it didn't. And I mean, to me it was so obvious I didn't even put it on camera, but what I did was I measured the write protect input on the disk controller over here, and while the disk was spinning, write protect, if you have a write protect tab on your disk, it will only pull that input low when the disk is actually selected and running. So I put it like in a format mode, something where it just ran and retried forever, and I slid a disk inside that didn't have a write protect tab, and the line on here stayed high. And then the minute I put a write protect tab on the disk and put it back in, the line went low. So yeah, it isn't that either. The write protect logic works fine. I put it back together, but I did swap the A and B drives, and I'll explain in a minute why I did that. But this is probably a good time to see if we can use this machine. So let's boot off a CPM disk. And tell it to copy itself to drive B. So here we go. And the reason I did this is that with the discs that come with the Osborne, since the machine comes standard with 2 drives, couldn't get them with 1 or no drives, a lot of the software is set up to use drive B as the data disk and drive A to hold the executables, overlays, and stuff like that. So when you're going through WordStar or whatever, it's going to need to keep the WordStar disk in drive A to load overlays and stuff like that, depending on what you're doing. But your data disk should be in B, so you can save your work there. So it looks like we're almost there. And of course the big test is to see if it'll boot off of the copied disk. So it says everything is okay. So let's take out the original and put in the copied disk. And it worked. So it works that way, as long as we don't format or write to the disk in drive A. And there you have it, the world's first commercially successful portable computer in mostly working state, except I got to teach that drive how to write. But it came back, which is a testament to how well it was built. Being a portable machine, it was probably banged around a lot, but nothing too serious. And I figured we'd have a quick look at some of the software that originally came with it. What you're looking at right now is the diagnostic screen for the diagnostics, which are very useful, not too badly written. I don't think they came with it originally. You have to be a authorized repair center. But so here's one of the first discs. And WordStar was basically, in my opinion, one of the first usable word processors. There were a lot of word processors on Radio Shack machines and others, but I'm not exactly sure that they were very usable. So let's see. What do we do? Create or edit a document file. Oh great, when you don't give it a file name it goes out. Okay. But now it's going to try to write the file to this disk. Nope. There you go. So there's your screen, and you will happily sit and type things on here. Now, there are some leftovers of WordStar even in today's computing world. When you hit Control-C to copy something in your text editor on a PC, that keyboard scheme was actually, that command scheme was introduced with WordStar, where you hit the Control key and then various letters did things. Control-V for paste, for instance, and all that sort of stuff. But that's about all that's left over from it. But once WordStar was out, all of the other development environments, Turbo Pascal and all of those, pretty much used the same command set for their program editors, just like WordStar. So for us who used this, who grew up in that era, The command structure of WordStar is basically in our blood. Next we have SuperCalc. So well, it's not really the granddaddy to Excel. That was probably even stuff before this. VisiCalc. VisiCalc was really the granddaddy to spreadsheets, but they didn't have a good business sense, so a lot of people came out with other stuff, and hit return to start, and there you go. There is your Lotus screen. Primitive, but probably really impressive in its day. And next we have Microsoft Basic. I think there were several flavors on here. Oh, it went right into Basic. There's a compiled version and an interpreted version, I think. But since we're in here, oh, where are things on this keyboard? I always have to put them in different places. Oh, there's a caps lock here too. Let's see if that works. It does. How about that? And finally, oh, it won't auto boot, but what this is, DBase 2. DBase 2 version 2.3. That should be a lot of fun to play with. I'm going to need DBase 2 soon to put all the equipment in there, because I'm running out of room and I can't find things in my work area anymore. So here's what you got to carry onto the airplane in 1981. Weighed 25 pounds. And good luck getting this through airport security nowadays. But that's what it was. Real leather handle, real plastic. And that's of course another thing I wanted to show you. I think initially I showed you some of the discoloration, which we basically have there was something laying on here. And I think this was up here because this part was the same color as this, and then we had like a gradient going, getting a little lighter here. Here it's really extreme. And what I did, the reason is this is lighter now. It is even, I don't know, you probably can't really see it, but it's even lighter than this. I tried to retrobrite it, submersing it in peroxide and putting it into the sun. And it worked and it didn't work. It worked because it lightened the color and it's kind of matching the top now. But looking at it more closely, you will see that it's streaked. Look, that looks like a cow. And I did some reading on it. That is one of the unfortunate side effects of retrobriting this. It's because of the type of plastic they used here. So I'm going to have to experiment with this a little bit more, and then I could make the machine perfect, along of course with a drive that's been taught how to read. So thanks for watching. I hope you can appreciate how bad some of us had it in those days, having to deal with this. This was our laptop, our iPad, our everything, when we were on the road, of course. But things have come a long way. A thumbs up would be appreciated. Leave me a comment, especially if you found any fault in my logic diagnosing the problem in the head in the drive that doesn't work correctly. I'd love to hear your thoughts about it, and make sure to subscribe, because I have made yet another contact in town from whom I may be able to get some more interesting stuff to fix. See you later.